he has given velocity time graph, time in second, velocity in meter per second. Here 2 meter per second, 4 meter per second. This is for minus 2 meter per second, minus 4 meter per second. This is the graph given. Now he asked us to calculate average velocity from 2 seconds to 6 seconds. That means the slope of line joining 2 points gives you average acceleration from VT graph. So 2 seconds means this is the point, 6 seconds means this is the point. So we have to draw these 2 points with a straight line, so it makes an angle greater than 90 degrees with the time axis, so slope will be negative. Now we have to calculate that slope. So let me calculate this magnitude first so that I can assign sign. This tan theta equal to this opposite edge by adjacent edge. Opposite edge is, this is 4 units, this is 2 units, total is 6 units. 6 units by means 6 meters. So from 6 meter per second, from here to here 2 seconds to 6 seconds, so the time duration is 4 seconds. So average acceleration between 2 seconds to 4 seconds is equal to minus, because slope is negative, so acceleration, average acceleration also negative. So 6 meters by 4 seconds, from here to here it is 4 seconds. So what do you get? Minus 1.5 meter per second. Now let us calculate instantaneous acceleration. At t equal to 0.5 seconds we have to calculate, t equal to 2 seconds we have to calculate, at t equal to 7.5 seconds also we have to calculate, right? Now from VT graph, instantaneous acceleration, how to calculate dv by dt. That means slope of tangent drawn to the VT graph at particular point. Here at t equal to 0.5 seconds we have to draw a tangent to the graph, so we have to calculate slope of that tangent drawn to VT graph. Gives you instantaneous acceleration at t equal to 0.5 seconds. Now this is 1 second, now this is 0.5. This is the point. We have to draw a tangent, this is along straight line, so this straight line slope gives you tangent slope, and it gives you instantaneous acceleration at this point, at this time t equal to 0.5. So its slope means this theta, tan theta means this opposite by adjacent, that is 4 meters by 1 second, that is 4 meter per second by 1 second, so 4 meter per second square. So at t equal to 0.5 seconds it is 4 meter per second by 1 second, that is 4 meter per second square. Next, at t equal to 2 seconds, this is the point. If you draw a tangent, it is along, it is parallel to time axis, so its slope is 0, so instantaneous acceleration is 0. Now at t equal to 7.5 seconds, so this is the point. Now you have to draw a tangent, it is along this straight line, so it makes an angle less than 90 degrees with the time axis. So tan theta is positive, so slope will be positive, that means instantaneous acceleration at this point is also positive. That means tan of this angle, but this tan of this angle is same as tan of this angle, so this opposite by adjacent, this opposite edge value is 2 meter per second and this is 1, so 2 meter per second by 1 is 2 meter per second square. Now displacement of the particle from 0 to 5 seconds. When VT graph is given, how to calculate displacement? Displacement is equal to area between V of t graph and time axis that we have studied. That means we have to calculate area between this graph and time axis up to here, so this complete area and also this area, but here this area will be negative and this is positive, so positive plus minus of this value gives you total displacement. And this area, let me calculate this area is equal to area of this triangle, area of this rectangle plus area of this triangle, right? That means displacement dx, integration dx is equal to integration v dt, v of t dt. It gives you area between v of t graph and the time axis. Integration dx from x1 to x2 gives you x2 minus x1, that is displacement, right? Now let us calculate area. That area is equal to, from 0 to 4 it is positive, from 4 to 5 it is negative. So this positive plus of minus this negative area gives you total displacement. So this is triangle, half into base 1 into height, that is 4. Half into 1 into 4, 4 by 2, that is equal to 2, plus this rectangle from here to here 3 minus 1, that is 2 units, 2 seconds, and this 4, 2 into 4 gives you 8 meters, into same half into base 1 second into height 4, that means 4 by 2, that is 2. This is positive, plus this is again negative. So here half into base into height, half into base is this 1 second, height is 2. What do you get? 2 by 2. 2 by 2 is 1, so minus 1 it is. So what you are going to get? 2 plus 8, 10, 10 plus 2 is 12, 12 minus 1 is 11, 11 meters is the displacement from 0 to 5 seconds. Now distance of the particle after 8 seconds. What do you mean by this? Distance, he has used the term distance of the particle after 8 seconds, means at what shortest distance it is there from origin after 5 seconds, after 8 seconds. That means we have to calculate displacement in 8 seconds. So you can understand this. Here one situation, this is x-axis. Let me take from here to here, acceleration is positive, so velocity gradually increases, uniformly accelerated motion, so like this. Next, from here to here velocity is constant, so velocity with uniform velocity, acceleration is equal to positive. Now from here to here velocity is positive only, because on positive axis we are considering, so its direction of motion is along positive x-axis only, but the magnitude of that velocity gradually decreasing. That means speeds up like this, it slow down, slow down, slow down, slow down, like this. Finally velocity becomes 0. Now velocity will be negative, because velocity we are taking on negative axis. Velocity is negative, means its direction of motion has been changed. That means like this. And 5 seconds, after 5 seconds, again it accelerated in negative direction, like this. Speeds up. Now here velocity is constant, again with the uniform velocity, it moves. Next, here velocity value is negative, means direction of motion is same along negative x-axis side only, but its magnitude gradually decreases, so slows down, slows down, slows down. Suppose if it is here, now this question is distance of the particle after 8 seconds, means from origin at what distance it is. That means simply we have to calculate displacement value in 8 seconds. That's all. Now displacement value in 8 seconds means this total area plus this area, but below this axis we take it as negative. So above this axis positive we have calculated already, that is 2 plus 8 plus 2 and plus minus 1. This area already we have calculated, and this is a rectangle, so this length is 7 minus 5, that is 2 units, and this is also 2, so length into breadth, 2 into 2 4, so minus 4. Again this half into base is 1, height is 2. So 2 by 2 is 1, that is minus 1 again. So what you are going to get? Here 12 minus 6. 12 minus 6 is 6 meters. So it is at 6 meters distance from origin. If it starts from origin, means initial position to that point, 6 meter distance. Now distance traveled by the particle in 8 seconds. See, the main difference between these two sentences you have to understand. Distance of the particle after 8 seconds means where it is after 8 seconds, that is what we have to calculate, means displacement. Distance traveled by the particle in 8 seconds, so complete distance. And we have seen distance means, suppose if it came to here, what do we have to calculate? This value plus this value. Distance is a scalar quantity, so we have to add this value plus this value. But as far as the displacement is concerned, this vector is positive vector, this vector is negative vector. That's why we have added those vectors vectorially. But as far as the distance is concerned, this is positive, this is again positive. So this is the total distance traveled. That means even this area also we have to take it as positive. That means the same 2 plus 8 plus 2 plus positive values 1 plus 4 plus 1. That's all. So what do you get? This 12 plus 6, that is equal to 18 meters is the distance traveled. Distance traveled by the particle in 8 seconds. So from VT graph, if we talk about the slopes, you will go for acceleration values. If you talk about the areas, you go for displacement values.